So our abbreviated version of this, because we didn't hit the start button, or I didn't, looks like this. We're going to take this equation and rewrite it to put it in the proper form. So I'll move the 2 to the left-hand side and then complete the square on what's left here on the right-hand side. That means factoring out the -3 to begin with, because when I complete the square, I have to do it with something that has a coefficient of 1 for the x squared. So when I factor out the -3, that leaves behind x squared minus 2x. Completing the square on this means I'm going to put a 1 in the parentheses. But putting a 1 in the parentheses means -3 times 1 is the net effect to the right-hand side. So I've subtracted 3 to the right-hand side. I'll subtract 3 to the left-hand side by adding -3. Combine the like terms, and then move the 1 to the right-hand side. You can write your parabola in this form or in this form. The nice thing about this form is that you can just look at it and read off the vertex. 1 is the value of x that makes the square term equal to 0. And if that's 0, you get 1 for y. So there's your vertex. As convenient as this is for the vertex, the other equation, the other form of this, is more convenient for the y-intercept. You get the y-intercept by setting x equal to 0. These two terms disappear. What's the y-coordinate of the y-intercept? Good, -2. Now comes the fun part, finding the x-intercepts. So to find the y-intercept, I set x equal to 0. What do I do to find the x-intercepts? Good, set y equal to 0. Now I'm going to do that with this one up here. So I'm going to write 0 equals -3 times x minus 1 squared plus 1. And for my convenience, I'm going to move this whole term over to the left-hand side. So instead of moving just that simple little 1 to the left-hand side, I'm moving everything else to the left-hand side. Can you suggest why I did that? Yeah, you get rid of the negative. Perfect. That's exactly why we did that. To finish solving here, I'm going to divide both sides by 3. And then take the square root. Of course, hopefully you won't write just something like this. What's wrong with that? Yeah, I need that plus or minus. So I want that plus or minus. And then I'll move the 1 to the right-hand side and get 1 plus or minus the square root of 1/3. So there's really two x-intercepts there, the positive root and the negative root. Let me put those on my little t-table, but leave a little space. I'm going to write 1 plus the square root of 1/3 and 0. Leave some space underneath the x-coordinate, and then 1 minus the square root of 1/3 and 0. No, because when we move the 1 to the right-hand side, it changes sign, so it's positive 1. Now, thing is, when you graph this, you're not going to know exactly where to graph this. Most people aren't going to know where to put a dot for 1 plus the square root of 1/3. So that's why I had you leave a little space. We're going to come up with a decimal approximation. I think it's about 1.577, but I was never very good at math, so don't trust me on that one. Let's do it here. Yes, sir. Yeah, so if you wanted to compare it, if you do x equals -b over 2a, it'd be the negative of 6 over 2 times -3, which would be -6 over 6, which is -6 over -6, which would be positive 1. So you would get the same thing, right? You get x equal 1 for the vertex here, and we got x equal 1 doing it our way. So they both work. It's just a matter of what you find convenient in terms of finding the vertex. This process, though, the process of completing the square, is something that I want you to know. Take out your calculators. Let's do 1 plus the square root of 1/3. So second square root 1 divided by 3. Bam. Oh, boy. Now, we need the minus root. Here's a little trick for you. If you hit the second key and then the enter key, then it'll pull up your previous calculation, and we only got to make one change here, right? Change that plus to a minus, and now you've got both possibilities. Round it off to the nearest tenth, about 1.6 and about 0.4. So, a little while ago, I encouraged you to leave a little space here. 1.6 and about 0.4. And that's because this is going to tell you where you're going to put this on your graph. So let's do that. Let's put it on our graph. We'll graph the easy points first. 1 and 1, right up there. And then 0, -2 is down here. For these other 2 points, you can use the approximation, but if you look on the x-axis, I've got this nicely spaced off so that each tick mark is about a tenth. In fact, it's exactly a tenth. So I want one at 0.4 and one at 1.6. That should be enough to give me a good graph, but you can get another point kind of for free based on all our work here. Keep in mind that the graph of a parabola is nice and symmetric. The line of symmetry goes through the vertex. 2 to the left, I've got my y-intercept. So 2 to the right, at this point, I get another point. I get a mirror image. So if I wanted to throw that in there just to help me draw my graph, great. You don't have to, but, you know, it doesn't hurt. There, and sorry for any vertigo to my viewers. There we go. So there's your graph. So not too bad. But the points that we found here are the ones I'm going to be asking you for. The x and y coordinates of your intercepts, and then the x and y coordinate of your vertex. Looking okay on problem number 20? All right. Let's try another one. Let's see which one it's going to work with. There's one that corresponds to that function I had you put in your calculator earlier. I'm just going to find it here quick. Oh yeah, 46. Yeah, here we go. So we did a lot of work here. We got a lot of points, and all the little parts of it are things that I'd like you to be able to find. But let's keep going. Let's try problem number 46. And I'm going to show you, remind you of some calculator tricks. Problem 46 gives you something like this. Y equals negative square root of 2 x squared plus x plus 1. You could be asked to find just the vertex. And we've got a nice formula for finding the vertex. I wouldn't want to try and complete the square on something as nasty as this. That'd be majorly unfun. So I'd probably use the formula. That's your other avenue to try and find the vertex. In this case, what's the value of b? 1. And what's the value of a? Negative square root of 2. Now in the denominator, let me just move that out of the way. I'll move it out front. Negative 2 square roots of 2. And even then, it's kind of ugly. So what I could do is I could rationalize this. If I multiply by 1 in the form of the square root of 2 over the square root of 2, then I end up with square root of 2 over 2 times the square root of 4, which is square root of 2 over what? Yeah, 4. Because this is really 2 times 2. So I'll have a 4 in the denominator. So that should be the x-coordinate of my vertex. Let's see that that's true. So let's see here. Square root of 2. And then you want to exit that. So you press the right arrow, divided by 4, should give me 1.17 or something? No. No. Oh, I was way wrong. Oh, I'm thinking the y-coordinate. Okay. The negatives cancel each other out right here. So the negative and negative is a positive, so those cancel each other out. All right. So about 0.35, 355, etc. Is that what you guys are getting? Okay, good. Let's graph this. So earlier we put these into our graphing calculators. Go back and press the Enter key on that equals button to kind of highlight that. Let's set up our graph. Let's see, this is going to open down. I don't know, I'm going to go negative 3 to 3 on the x-axis and negative 4 to 2 on the y-axis. So with those settings, let's just hit the graph key, see what we get. And a nice parabolic shape. Now I want to confirm that I had a maximum at this point. And we already figured out that this is about 0.35 something. Let's see if we can't confirm that again this way. Just a little reminder on finding maximums. Remember what menu to go to find a maximum? Yeah, it's the calc menu. So second trace helps you find a maximum. So left bound, we can just use 0, which is what the calculator is kind of suggesting anyways. Right bound would be 1. That'd be pretty good. So just type in the number 1, press the number 1. When you press enter, that gives you the range it's going to find a maximum of. It asks for an initial guess, just press enter again. That's easy enough to do. Notice that this maximum, the 0.3535, matches what we calculated earlier. So that's your maximum. And as a bonus, you get the y-coordinate of the maximum, 1.17, etc. Okay, how are we doing with those last little bits on the graphing calculator? All right on that one? Now, I've sent you some homework. We'll do a couple more problems on this stuff next time, but homework should be in your email, so unless there's some more questions, we'll stop this.